Discuss about problems on equivalent resistance. Okay, now see the problem. Calculate total current I. Okay, here I don't know about nodal analysis and I don't know about mesh analysis. I don't know any one method. Okay, just by using equivalent resistance method only I can calculate current flowing through the 10 ohm resistor. That means total current. Okay, that is the current flowing through battery also same, right? Now see here, for this type of problems, okay, here I need to calculate current on source side, right? That means here up to this point, just observe here, up to this point I can calculate equivalent resistance. Okay, here I need to calculate equivalent resistance between these two terminals, right? That means to calculate equivalent resistance between these two terminals, always I have to proceed from opposite end, right? That means first we need to proceed from this point. Okay, now see here, from this circuit, for example, assume total current is I. Okay, I is divided into I1 and I2, right? Okay, let us say here I, this I current is divided into I1, I2. Now see here, two different currents, and starting point of two resistors are connected to common point, finishing point of the two resistors also connected to common point, right? Now here this 20 ohm and 20 ohm are connected in parallel, right? Then the equivalent circuit will be 20 volt source, the 10 ohm resistor. Okay, next 20 ohm and 20 ohm are connected in parallel. Those two resistors are replaced by single resistor, that is 20 ohm in parallel with 20 ohm, that is 20 into 20 by 20 plus 20, right? You will get 10 ohms here, minus plus 20 volts, right? Here I need to calculate current I. Then total current I is equals to, voltage value will be 20 volts divided by 10 ohm plus 10 ohm, right? Then current will be 1 ampere. Okay, in this way we will get the current flowing through any resistance value. Clear? Okay, next we will discuss another problem. Determine equivalent resistance between A and B terminals. Okay, from the given figure I need to calculate equivalent resistance between A and B terminals. Now see here, we didn't identify whether the resistors are connected in series or parallel, right? See here, let us say assume 4 and 8. Okay, different currents starting in this different point, finishing in. Okay, I don't have any clarity, right? Hence I can redraw the circuit here. See here, this is node A. Okay, common, this line indicates same path. This is A, as it is here it is also A. This is also B, right? Same node. B same as B. That means this is a short circuit path, that indicates here B node, right? Same B node will be represented here. Okay na? Next, this is A, this is B, this is also B, right? This is different, right? That means I am assuming this node as C. Okay, that means the circuit is having how many nodes? 3 nodes, A, B, right? These two are common, right? A, B, C, 3 nodes. Here I need to calculate equivalent resistance between A and B terminals, right? For that purpose I can represent it, A and B terminals are outside. Okay, A and B terminals are outside. I need to calculate equivalent resistance between A and B terminals, right? I am representing C terminal here inside. Okay, now see here, A to B 4 ohm resistor. Okay, A to B 4 ohm resistor. Next, A to C 8 ohm resistor, right? This is C point. 8 ohms. Next, A to B is over, A to C is over. Next, B to C, right? B to C, 6 ohm resistor. Okay. Next, again B to C, 2 ohm resistor. See here, 1 2 3 4 resistors are present in the circuit. 1 2 3 4, right? Then circuit will be over, right? That means the equivalent, the resistance between A and B terminals here will be 4 ohms. A and C terminals will be 8 ohms. Now here we can easily identify whether the resistors are connected in series or parallel, right? Now see here, 2 ohm and 6 ohm are connected in parallel. Okay, 2 ohm in parallel with 6 ohm. You will get 2 into 6 pi, 2 plus 6, that is 12 by 8, that is 3 by 2 ohms, right? Then these two resistors are replaced by single resistor, right? Eight ohm. These two resistors are replaced by single resistor, that is 3 by 2 ohm. Now see here, 8 ohm and 3 by 2 ohm are connected in series, right? Then 8 plus 3 by 2, right? That is equals to 19 by 2 ohms. Then the resultant circuit will be, these two resistors are replaced by single resistor. The resultant value in parallel with 4 ohms, right? 19 by 2 can be represented by 9.5 ohms. Okay. Then the equivalent resistance between A and B terminals will be, when two resistors are connected in parallel, 9.5 into 4 by 9.5 plus 4. Okay. You will get the resistance between A and B terminals, that is 9.5 into 4 divided by 13.5. Okay, in this way you will get the equivalent resistance value. Okay, next see here, next last problem, calculate equivalent resistance between A and B terminals. Okay, that means here I need to calculate equivalent resistance between A and B terminals. Okay, this is starting in, this is finishing in, right? Here I need to calculate equivalent resistance between A and B terminals, right? Then I have to proceed from opposite end, right? Okay, for your clear understanding, for example, assume here current I is divided into I1, I2, I3. Okay, assume here it is I4, no problem, I5. Now see here, I6, same current is flowing through 2 ohm and 4 ohm, right? Same current is flowing through 2 ohm and 4 ohm. That means these two are connected in series. 2 ohm and 4 ohm are connected in series, right? Then the equivalent circuit will be like this. These two resistors are replaced by single resistor, that is 6 ohm, 3 ohm, right? 10 ohm, 6 ohm, 6 ohm, assume 3 ohms, again these two, starting end is connected to common point, finishing end also connected to common point, right? Then 6 and 3 ohms are connected in series. When 6 ohm in parallel with 3 ohm, 6 into 3 by 6 plus 3, you will get 2 ohms, right? Then the equivalent circuit will be like this. You will get here one resistor, okay. Right, 10 ohm, here it is 2 ohm, 6 ohm, 6 ohm, 3 ohm, right? Now see here, same current is flowing through 10 ohm and 2 ohm. Finishing end of one element is connected to starting end of another element. Now these two are connected in series, right? Okay, then the equivalent resistance will be yes. Here I need to calculate equivalent resistance between these two terminals, right? This value will be 12. Two resistors are replaced by single resistor. It is 6 ohm, it is 6 ohm, right? Here it is 3 ohm, right? Now see here 6 ohm and 12 ohm are connected in parallel. That is 6 into 12 by 6 plus 12, that is 6 into 12 by 18. 6 3s are 3 4s are, right? 4 ohms. Then the equivalent circuit will be like this, okay. AB, that is 4 ohm, 6 ohm, 3 ohm, right? Now here 6 and 4 are connected in series. These two are connected in series. Then 6 plus 4 will be 10 ohms. Two resistors are replaced by single resistor. 3 ohm, A, B, right? Then the resistance between A and B terminals will be, these two are connected in parallel. 10 into 3 by 10 plus 3, okay, that is equals to 30 by 13, approximately 2.3 ohms. The equivalent resistance between A and B terminals will be 2.3 ohms. Okay, in this way we can solve problems on equivalent resistance method. Okay, thank you all.